My name is Adam Romayor,
And I'm Michael Warren.
and this is our project, the Automated Drawer.
So the goal of our project was to create a machine that was capable of drawing on its own. And the technique we used was called Core XY, and it's a simple and straightforward technique that allows us to move a platform in the X and Y direction. And it uses these three plates right here. The first one is the one that the stepper motors are on. The second one is this platform right here that goes side to side that allows to move in the Y direction. And the third plate is going to be this one right here that allows movement in the X direction.
And like he said, this is a fairly straightforward and simple technique. And the way it works is we have these two stepper motors here, and depending on which way they rotate changes the motion of this platform. So if they rotate in the same direction, counterclockwise or clockwise, it'll either go right or left, depending on which way. And also, if they move in opposite directions, that'll get the plate to move up and down in the Y direction.
So the materials we use right here, we use two stepper motors, and we use these over DC motors because they're more precise, and we can tell exactly how many degrees to rotate. And we also use the Arduino right here, which is a microcontroller, and we use that to control the motors, the stepper motors.
And what we have here is the CNC shield, which is what we attached to the Arduino. And the reason we needed that is because the stepper motors alone, connected to the Arduino, would take up all the pins and it'd be too much. So this allows us to have several motors connected to it. And we also have these motor drivers, which simplify the interface and the wiring between the motors to the Arduino.
Alright, so this is our implementation. You can see the cardboard right here would be the first plate. The ruler going side to side is our second plate that moves in the Y direction. And this green square right here is the third plate that moves in the X direction.
And how our implementation works is we have these two motors here connected to the CNC shield, like I said before. And the way we communicate with these motors is using a program called Universal G-Code Sender. And what that does is it sends G-code to the Arduino, and the Arduino has some software on it that translates this G-code into a language that the motors understand to control this platform.
Okay, so we faced some challenges along the way making this. The first being the belt slipping on the gears, and that caused a loss in precision.
And the way we fixed this is that we increased the tension in the gear belt. And the way we did that is we simply moved each motor back a couple of centimeters. And what that did is it just, once again, increased the tension and solved that problem.
And the second challenge we faced were unstable pulleys. Basically, the four pulleys in the back, instead of facing straight up, they were tilting, and this also caused loss in precision.
And the reason that happened is initially we used toothpicks, which we realized did not work at all. So what we did instead is we got nails and we drilled them through rulers, and that was a lot more secure. So once we secured that onto the platform, it stopped moving side to side.
And the last challenge we faced was unsteady platform. Basically, the tension from the motors and the pulleys from the back was causing the cardboard to cave in a way.
And once again, rulers saved the day. We got the two rulers, put them parallel next to each other, secured them onto our platform, and that easily solved that problem.
Okay, so here are the basic applications that we can do with our project. We can do the basic shapes like squares and rectangles and triangles. We can also, with coding, do drawings. With more coding, we can do complicated drawings such as these. And we're also able to do text as well.
And if we use a different medium other than a pencil or pen, such as a blade, we're also capable of doing precision cutting, like for metal. Some people have done it with metal or cloth, which I've also seen, and which would also make this capable of engraving. And if we added a third degree of freedom in the Z direction, some people have used this for 3D printing, which is pretty cool. And one of my favorite quotes of all time, "Failure is the opportunity to begin again more intelligently," and this is by the great Henry Ford.
This was relevant to us because the first time we went through, it didn't really work that well. So we basically had to step back and figure out what we had to do better in order to make it work.
And here are our works cited. And thank you all for listening.